In this section, we will talk about how we can remove microorganisms from surfaces, including the body. The three terms that we'll use in this section are sterilization, disinfection, and antisepsis. You can see the definitions of each of these terms here. Antisepsis is the use of chemical agents on the skin or other living tissue to eliminate or inhibit microbes. And the second part, they don't kill spores. So the idea behind antisepsis is hopefully you can see that we may not completely remove all microorganisms, especially spore-forming microorganisms, but the idea is that we get the surface as germ-free as possible. Disinfection is the use of physical or chemical agents to destroy most microbial forms. Some more resistant structures like bacterial spores or other relatively resistant organisms like the mycobacteria, viruses, and fungi could remain viable. And we do break disinfectants down into high, intermediate, and low-level agents. So disinfection and antisepsis are a little bit different. Remember, antisepsis is going to be on living skin. So an antiseptic is something you use on living skin or other living tissue. A germicide is a chemical that's capable of killing microbes. And you can have virucides, bactericides, sporicides, tuberculosides, or fungicides. So it's just kind of a general term. A high-level disinfectant will kill all microbial pathogens except high numbers of spores. Intermediate will kill microbes except spores. And a low-level disinfectant will kill most vegetative bacteria and lipid-enveloped and medium-sized viruses, but definitely not spores. And then kind of the king of all microbial removal tools is going to be sterilization, which is the use of physical procedures or chemical agents to destroy all microbial forms, including spores. And in order to accomplish sterilization, you can see in this table, we have our physical sterilants, gas vapor sterilants, and chemical sterilants. So things like steam under pressure. This is going to be the use of an autoclave. Filtration, radiation, ultraviolet, or ionizing. Gas vapors including ethylene oxide, hydrogen peroxide vapor, and plasma gas. But remember, you're going to have to do this for specific periods of time at specific temperatures in order to have that sterilizing effect. So again, you have to reach the certain temperature for a specific time in order for all these things to happen. And then you have chemical sterilants, peracetic acid, and glutaraldehyde, again at specific percentages. For disinfection, we can use heat. So there's moist heat. So kind of a high temperature. This right here would be boiling for about 30 minutes. Again, this is not moist heat under pressure, which is what we see with an autoclave. There are also various liquids, glutaraldehyde, hydrogen peroxide, chlorine, alcohol, phenol, ammonia compounds, etc. So these are some of the things that you might be familiar with that you probably have used to, for example, disinfect your lab benches when you're in laboratory classes. And then for antiseptics, we also have alcohol. So alcohol can be used as an antiseptic, meaning you can use it on skin, or it can be used as a disinfectant on a surface like a lab bench. Iodophores, chlorhexidine, triclosan. So these are things that you can use on living surfaces and might be used in surgical settings. And then here it shows you various disinfectants and antiseptics. Remember, sterilants won't be on this table because sterilants remove everything. But if you look at this table, it gives you your disinfectants and your antiseptics and how it works against various groups of organisms. So bacteria, mycobacteria, spores, fungi, and viruses. For mechanisms of action, all of these different antiseptics, disinfectants, and sterilants can do different things in order to kill or remove microbes. So when we talk about moist heat, specifically autoclaving, this is kind of the gold standard for how you can remove microorganisms completely from a surface, including spores. So we use this to sterilize growth media before you do the Bio 120 lab. We can use this to sterilize biohazardous waste. The autoclave is a very, very important tool, especially in the teaching and clinical laboratory setting. Autoclaves are also useful in places like dentist's office, tattoo parlors, nail salons, etc., where you have metal tools that are constantly being exposed to other people's bodily fluids. So again, the dentist, they're playing around in your mouth, surgical tools, of course, that cut the body, piercing studios, tattoo parlors, and hopefully your nail salon. So anytime you go to the nail salon, if they have a tool, they should be opening it from an autoclave pouch, unless it's a disposable tool that should be thrown away after each person has come through. Ethylene oxide is used for heat-sensitive materials. So sometimes there are things that perhaps the high heat of autoclaving would actually destroy that object. Maybe plastic tubing that needs to go in a patient or carry fluids to a patient that still needs to be sterile. It can't have any contamination or it could make the patient very, very sick. But if we put it in the autoclave, it'll melt. There are also liquid media that if you put them in the autoclave, it will denature the compounds in the media and make it so that microbes won't grow. So there may be reasons that we need to have an alternative type of sterilization. So for a liquid that you want to sterilize but you can't autoclave, you can filter sterilize it using a very small filter to remove everything. But for other things, you can use like ethylene oxide gas. So that's used for heat-sensitive material. Basically what happens is reactive groups get alkylated and that prevents metabolism. So because we're talking about preventing metabolism, this has to go on longer than an autoclave because we have to give it a chance. We have to have all the microbes doing their metabolism in order to be inhibited. For both the moist heat and the ethylene oxide, so basically for the autoclave and for the ethylene oxide, we'll use what's called a spore test in order to determine that it works. And so periodically, for example, with the autoclave, Mark will go in and he'll put spores in the autoclave, like a culture of bacillus spores. And if those propagate after going through the autoclave cycle, that means the autoclave cycle wasn't effective. But if they don't propagate after the autoclave cycle, that means the autoclave is good. And so we can continue to use it. Same thing with the ethylene oxide. We just expose the spores to the sterilant. And as long as they don't propagate after the procedure, then we know we're good. Aldehydes are bacteriostatic at low concentrations. They are toxic to humans, so we wouldn't want to use these as an antiseptic, but they may be good as a disinfectant. Oxidizing agents can form free radicals, which will kill microbes. They can affect DNA and proteins. Halogens can precipitate proteins and oxidize essential enzymes. Phenols disrupt lipid membranes, which is why they can be effective against some viruses. So if we disrupt the lipid membrane, the cell will basically fall apart or the viral particle will fall apart. And again, this is why phenols aren't great as antiseptics, because you don't want to put them on your skin because your skin has lipid membranes, but it wouldn't be so bad to put them on a surface and use them as a disinfectant. Ammonia compounds also denature cell membranes and can be bacteriostatic at low concentrations. Alcohols denature proteins and dissolve lipid membranes. And so alcohols are one of those tricky things that we sometimes do use as an antiseptic. For example, if you have like an antibacterial hand sanitizer and you take a look at the back of it, you'll see that it contains alcohol. But as maybe you noticed during the past 3 years of COVID-19, that if you use too much hand sanitizer, it really does a number on your hands. Your hands will dry out significantly. And that's because while it, yes, does kill microorganisms and gets rid of COVID-19, it also can damage the cells of your body because your cells have lipid membranes. So it'll really dry out your hands. So we don't recommend using too much alcohol as a hand sanitizer. What I want you to think about as you start reflecting is maybe think of other examples in your reflection, include other examples of situations where something could be a great antiseptic, but maybe not a disinfectant. Or something maybe could be an antiseptic and a disinfectant. So think about things that you use in your daily life that also work as antiseptics or disinfectants. I imagine most of you don't have sterilants at home, so that's why I focused on antiseptics and disinfectants.